Okay, plowing forward. Mom is a carrier for hemophilia, and dad has normally clotting blood. They've decided to have a child, and they've come to you for genetic counseling. First, which pattern of inheritance is going to be exhibited in this case? Hemophilia is a condition that is characterized by sex-linked inheritance, specifically X-linked recessive inheritance. And that has its own unique inheritance pattern that we'll talk about here in just a second. Next, it asks us, what will the genotype ratio be for that child? Okay, since we're dealing with a sex-linked condition, we're going to represent on our Punnett square XY versus XX. XY represents dad's sex chromosomes, and XX represents mom's sex chromosomes. Now, we've been told that dad has completely normally clotting blood and that mom is a carrier for hemophilia. Let's let capital H represent normally clotting blood that resides on the X chromosome, and lowercase h represent hemophilia residing on the X chromosome. Dad only has one X chromosome, and we know dad has normally clotting blood. By definition, we can give dad an uppercase H on his X chromosome. Mom is a carrier for this condition. She's not affected by the condition. She's a carrier. So one of mom's X chromosomes has a capital H, and the other one has the hemophilia. Notice there's no competing hemophilia or non-hemophilia representation on the Y chromosome, just on the X chromosome. What we're going to see that means is that for individuals who are XY, or in other words, for individuals who are male, whatever they get from mom is going to be the type of blood clotting that they exhibit. If they get the hemophilia allele from mom, they're going to have hemophilia, even if they only have one copy. So let's plot out this Punnett square. First, two X chromosomes with a capital H. This is going to be a girl who is completely unaffected, as well as not being a carrier. Our first boy, who's going to have normally clotting blood on his X chromosome. Another X, and I'm going to do this a little bit backwards for continuity's sake. Lowercase h. So we're going to have one carrier there, female. And then, the other boy has hemophilia. So what is our genotype ratio? So we have one female completely unaffected. Below that, we have one female carrier. Then we have one male unaffected, and we have one male affected. So if we don't consider carrier status, and we just consider genotype ratio for right now, then what we see is that we've got a different genotype for each portion on our Punnett square. And so for our genotype ratio, we would be talking about 1 to 1 to 1 to 1. For our phenotype ratio, Remember, female carriers of hemophilia aren't partially affected with hemophilia. They're either affected or they're not affected. And if you're a carrier of hemophilia as a female, you're not going to be affected with the hemophilia. So phenotypically, again, you either have normally clotting blood or you have hemophilia. So for our phenotype ratio, we can say 2 to 1 to 1. So 2 to 1 to 1. How does that break out? So the 2 is going to represent, we'll say, female and non-hemolytic, to 1 male non-hemolytic, to 1 male with we'll say A, which is affected. Finally, our challenge question lets us know that an amniocentesis has been performed and it indicates that the child is going to be male. What is the likelihood that this child is going to have hemophilia? Well, by now y'all are on your toes when it comes to these challenge questions. So I have no doubt that you will not be surprised when I tell you that it's a 50% chance that this child is going to have hemophilia. But Professor Recore, you say, in that 2x2 Punnett square, the only one indicating to me hemophilia is the one in the lower right, representing it to be a 25% chance. And you would be right if we didn't know the sex of the child already, and we were just talking about percent likelihood of any child having that condition. But we've been told that baby is going to be baby boy and not baby girl. That means this eventuality and this eventuality is a non-starter. So we're only going to be looking at this square and this square. And in this case, one of those two squares represents hemophilia, the other one represents normally clotting blood. So baby boy, the percent chance he's going to have hemophilia is going to be 50.